Morning. Let's quickly look through this matrices uh, ac- actions. Okay. Um, all right. Fantastic. So I'm trying to test my marker. You can see it's working well. I can pick colors. I can do everything now. All right. So now let's talk about addition of matrices. Okay. So we're looking at matrix addition. We look at matrix addition first. Then we look at matrix multiplication. Then we look at inverse of matrices. We look at inverse of matrices. All right. So under this inverse of matrices, if we can do the inverse of matrices, if we know how to do it, then it means that we can do the division of matrices. Well, of course, there are conditions that we have to satisfy before we can do any of this stuff. It's not like you can add any two matrices together, or you can multiply any matrices. Nope. And it's not every matrix whose inverse you can get. So if you can't get the inverse of every matrix, then it means that you can't do division of every matrix. Okay. So having said that, let's just for uh, like a rundown, let's quickly look at what a matrix is. So a matrix is often an array like this that you put items inside numbers, basically numbers. Or so we can have 1, 2, 3, 4, 5, 6, 0, 1, 0, 1, 9. So this is a matrix. Okay, now let me talk about the parts of a matrix. So you can see that we call this a 3 by 3 matrix because it has three rows. These are the rows. That's row 1, row 2, and row 3, and it has three columns. That's C1, column 1, column 2, and column 3. Okay, so we start. That's is a row by column. So it's a 3 by 3 matrix. This particular one. If we look at something like this, let's say it's 2, 2, 1, 2, 3, 4. You can see that it has only two columns, C1 and C2, and it has three rows, R1, R2, and the R3. So it has three rows. Like I said, it's usually R by C, so it's three rows by two columns. So that is the whole. That's like the starting point for talking about matrices. Let me save this page. Okay, now let's talk about the addition of matrices. I'll probably send you the save pages later. Addition of matrices. Addition of matrices. Okay, now maybe okay. I may partition it later, but let's see. Let's look at this is the process of addition of matrices. Then the condition for addition of matrices will automatically come out if I show you the process of addition. So let's say we have a matrix. Let's say this is A, which is A, B, C, D, and this is B, another matrix B, which is E, F, G, and H. All right, so then we can say A plus B, that is when we're adding the two, it is you take corresponding items and add them. This is going to be, so A is here and is corresponding to E here. So there's going to be A plus E, and B is here, is corresponding to the item F here. So this is going to be B plus F, and C is here, it's corresponding to this guy here. So this is going to be like C plus G, and there's D here, which corresponds to H star. So this is going to be like D plus h. So let me close it like that. It's already falling under the line. Sorry about that. So that is usually the addition of matrices. So if you can see, so it means that if two matrices do not have the same dimension, that is, they don't have the same rows, the same number of rows, and the same number of columns, then you can't add them. You cannot have them. For instance, let's put numbers into this one. So we'll see. So this is A. Let's say it's 1, 2, 3, 4, 2, 5. And then this is B, which is 1, 1, 0, 1, 2, 3. Then you can say A plus B equals, of course, you can start adding the items in there. That's 1 plus 1, which is 2. So, okay, 1 plus 1 gives you this 2. Then 2 here plus 1, that's 3. That's 3. Then 3 here plus 0, that's 3 still. Then 4 here plus 1, that's 5. 2 here plus 2, that's 4. And 5 here plus I think this is 5. Let's call this 5. And 5, that's going to give you 10. So you have added the two matrices successfully. However, if we have A to be 1, 2, 3, 4, and we have B to be 1, 1, 1, 2, 3, 1. Okay, it means that this is a 2 by 2, and this is how many rows does this one have? It has 2 rows. How many columns it has? So this is 2 by 3. You can't have this because, okay, let's assume you are able to add 1 and 1 and 2 and 1. What will you be adding to this one here? Nothing. Okay, so you can't add those two matrices. So for you to be able to add two matrices, they need to have the same. They need to have the same rows and the same column. Now, let me let me save the page so we can move on to another to a strange kind of example. We've done the direct example. Let's look at a strange kind of example. So I've cleared the page. All right. So I've marked out. So let's look at this example. This is a tricky one. This is a tricky one. So it says further example. Further example. So we have, it says find the variables in the system below. So we should find the variables in the system below. So we have the first matrix, which is x 3, 5, then 5y 2. Then we have 1, 1, 0, and we are asked to add it to 3, 1k, 2yx, and 1, 2, 1. So, and they say the answer will give us 3j, 6, 7, 6, 8, and 2t1. So we have to find x. Let me change the color. Let's see if I can change the color. Okay. 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 So we have to find x. We have to find y. Of course, we have to find y here as well. We have to find x. We have to find k here, and we have to find j and t. All right, those are the items we have to find. So let's look at x. We know that if we had this x plus 3, then it must give us 3. So that's x plus 3 equals 3. This automatically, what are you going to add to 3 to give you 3? That's 0. So you have found the x to be 0. So automatically we have found the value of x here. It's going to give us 0. All right, so x here is 0. So the next thing we want to find, let's look at y. So we know that if we had y to, oh, it's corresponding to y as well. Y, okay, fine. It's giving us 6. It means that we had two y's together, then we have 2y, and it's giving us 6. This implies that y equals 3. So we have found y, which is 3 here. This one is also going to be 3 there. Okay, xy, we found that. What else? I think we don't have anything to find on the first matrix again. We have solved that one. Here we need to find k. We need to find k. Okay, we have found y, we have found x, so we need to find k. So we know that if we had 5 to k, it must give us 6. So automatically it means that our k equals 5 minus 6, sorry, 6 minus 5, which is 1. So we have found that. So we have resolved everything we need to resolve in the first two matrices. So let's look at the third matrix. So we have to find j, and we have to find t. So for j, we know that if we had the middle items, it must give us j. That's simple. That's 3 plus 1 equals j. So it means that this implies that our j is going to give us 4. So we have done that 4. And t, of course, well, I really think that's quite simple. Here's t here corresponds to 2. And okay, that's 1 plus 2 equals to t, which implies that your t is equal to 3. So that is basically everything you need to know about matrix addition. It's as simple as that. Now, I know it's you are familiar with it, but then I need to talk about it because it may help us later when we do something more important. I'm saving the page now, and we are moving on to the really tricky part, matrix multiplication. Now, let's look at matrix multiplication. Like I said earlier, it's not every I think let me pick something more exciting in terms of color. Let me, yeah, okay. So we're looking at matrix multiplication now. Multiplication matrix multiplication. All right. So what kind of matrices do we multiply? It's not every matrix you can multiply. So we're going to talk about that. So let's say um let's okay let me ask condition what uh, the conditions for two matrices to be multiplied, or as we say, when is when are two matrices, when can two matrices be multiplied? Okay, when can two matrices be multiplied? That's a better. Let me see if I can bold. Okay, okay, better. All right. So okay, okay. All right. So let's look at the first matrix. Let's look at the first matrix that we want to look at. I'm going to draw a matrix. It's going to be a little bit big. That's we're calling it A, B, C, D, E, F, G, H, I. Then we can have J, K, L. This is the first matrix, and I'm going to call it matrix A. I'll say now I'm going to call this A B. I'm going to say let's say M N O P Q R S, T, and U. Okay, those are the two matrices that I have created. Now let's look at the dimension of these two matrices. So if you look at this first one, it has how many rows? It has 4 rows. Row 1, row 2. Okay, let me just to make it more interesting, let's pick a different color. Okay, so it has a row 1, that's R1, R2, R3, R4, and then you have C1, column 1, column 2, column 3. So, and like I said, we name it as R by C, so it's going to be 4 by 3. Now here, the same thing. This obviously R1, R2, and R3, and this is a C1, C2, and C3. So it means that this R by C is a 3 by 3. Now, the main condition for multiplying two matrices is that A times B, that is the column of the first matrix A, which is in case 3, must be equal to the number of rows of the second column that you are multiplying with. If they give you two matrices that are not like that, then you can't multiply them. For instance, let me shock you now. We can do A times B can be resolved in this case because the columns of A is 3, and the rows of A is 3 as well. But if we switch it, let's look at B times A. If you look at B times A, let me see. Okay. All right. Sorry. If you look at B times A, then we are looking at 3 by 3 and 4 by 3. The column of B is 3, and the rows of A is 4. It means that the column of B, this is B now, this is A. So this and this, they are not equal. So we can multiply it, even though when you reverse the rows, you can multiply it because 3 and 3 are equal here. All right, so the reason why that is so, I'm going to show you soon. Okay, now the next thing you must know is that now that we know that 3 and 3 are equal, then we know that we can pass, just like when we talk about addition of matrices. If the dimensions are equal, then we can go on. In this case, if the column of the first matrix is equal to the row of the second matrix, then you can multiply the two of them. Now, the result, this is also very important. The result will now be the row of the first and the column of the second. So the result will be a 4 by 3 matrix. Okay, so if you multiply a 4 by 3 matrix by a 3 by 3 matrix, then the result will be a 4 by 3 matrix. That's just it. All right. So let's now that we have talked about the background of multiplication, we can now see definitely that multiplication is not always commutative. That is, A times B is not always the same thing as B times A in the multiplication of matrices. Whereas in addition, it is so. It is so in addition. Now let me save the page, then we can move on to the next item. All right, now let's talk about the multiplication now. Let's talk about the multiplication, the process of multiplication. Okay, okay.